Okay, thank you for the introduction. Today I'm here to show you a practical case that we had learned last year. That was output of a project that were involved. We have people from Portugal and also from Poland involved in this project. So I split this presentation in 4 topics, starting with your background, after the methodology that we implemented, developed, the case of study, in this case, a railway bridge, and we finish with the conclusion. So I believe that we all agree that the number of bridges that we have today had the boom increase after the Second World War, mostly because of the road development efforts in the United States and Europe. And we also know that this bridge was designed for a life cycle of 50 to 100 years. But during this boom, we forgot that we had bridges built before, and it brings us some troubles. Like in 1967, a bridge collapsed in the United States. It was a new bridge, only 39 years, and it had some fatalities. And also in Portugal in 2001, a centenary bridge collapsed and killed 59 people. And after these tragedies, we can see that the states start to care about their bridge system and start to be mandatory some regular and periodic inspection implemented by a bridge management system. And now we live in an era of digitalization and where new technologies are accessible, and we need to learn how to implement them to improve our pipeline. So the objective of this work was create a hybrid rise capture framework using 2 kinds of technologies, active sensor and a passive sensor, that is photogrammetry and laser scanner, in order to determine the condition state of existing highway bridge. And also detect the geometry deviation based in the 2D drawings that we have from the design phase of that bridge. So the methodology proposed, it was divided in 5 steps. The first one was the recognition and preparation for the campaign. So where you could have access to some drawings of the bridge. We visit the local to see where to fly with the drone, where we have to set up our laser scanners. It was a recognition task. Later, we went to the field. We performed the data acquisition with your drone and also with your laser scanner. The final model was a hybrid model with both technologies, create a feasible model of that bridge. We went back to the as design plans to verify the geometry, and we performed our virtual visual inspection, observing if there was any deviation or anomalies. For this method to be applied, we had here some resource. That was a DJI Mavic 2 Enterprise Advanced with RTK system. That is a system that improves the performance of the precision of the coordinates of the pictures. We have a laser scanner BLK 360, and we have a computer with high performance. It was a graphical card 3090. And in terms of software, we use the Lycan solution for laser scanner and the Bentley solution for photogrammetry. In geometry analysis, we use open source software, that is Cloud Compare, to perform some geometric analysis. Our case study was that bridge, that is not in Venice, but this city is known in Portugal as Venice Portuguese, that is located in the middle of Portugal, in the central area. It's called Aveiro. Our bridge has 976 meters, but our focus was to perform the reality capture only in the first module. The first module has 100 meters and 4 spans. here we have the phase that we were acquiring data. So you can see there the laser scan, working, as well as the drone. And we also have the support of a surveyor to georeference our model. Our flight plans were divided into phases. The blue one was the lateral. We were flying around 3 meters from the bridge, and the top flights were around 20 meters for safety reasons. We're not allowed to fly in the corridor of the bridge, of the railway infrastructure, sorry. And here is the setups where we make the measures with the laser scanner. It was in total 115 setups. So we did the hybrid processing mode. We get here a high texture model. Here this model had a resolution around 1 millimeter per pixel. So it was highly precise. And we could cross the total section of the bridge. And finally, we performed the deviation analysis. So we did some semantic segmentation of the faces of that bridge. Each had a manual fine tuning. But with that, we could compare the measures in the long 100 meters. So we have there the average and the standard deviation. The measures was pretty close. It was what were expected. Since the bridge, it was new, it was around 12 years, we were not expecting high deviations. So with this work, we learn how to generate a 3D model using a hybrid processing methodology. This enables create an inventory of that bridge for future corporations. And also envisaging the creation of a BRIM model and digital twins. And since you have geometric information, you can update our structure models to perform some simulation. For future studies, we propose automate the UAV flight, as well as the second phase of our project is implement some damage identified on the 3D model, and they also improve the algorithm for surface segmentation. So thank you all for your attention.